Schwartz, one of the secondary math specialists with Montgomery County Public Schools. Today's video is called Lining Up Quadratics, and we're looking at linear factors as solutions to quadratics. The learning from this video is actually a part of Unit 4, Topic 3, and is introduced in Unit 4, Topic 2. However, all of the content of this video, while introduced at the very tail end of Marking Period 3, is actually assessed in Marking Period 4, which is why we're introducing it as part of the Marking Period 4 learning. In Unit 4, Topics 2 and 3, the students learn about the structure of quadratics by exploring patterns in diagrams, tables, and graphs. Some of the key ideas include that quadratic functions are the product of two linear factors. The linear factors of quadratics can be used to determine solutions to those quadratics. Some of the helpful skills that students have learned in previous courses include that multiplication can be modeled as an array of length versus width. This is done in elementary school, and it's done in Math 6. It's also done earlier in the Algebra 1 curriculum. Students also learn that linear functions may have one x-intercept. That's done in Algebra 1. So let's start talking about linear factors. In earlier videos, we explored the quadratic relationship modeled in the sequence below. We saw that at stage 1 there were 2, at stage 2 there were 6, and so on. And through the process of visualizing these diagrams, we realized that there is a width of x and a height or length of x plus 1, or whatever the stage is, times the stage and one more than the stage. We also explored factoring as an expression of tile or area diagrams as modeled here. In this particular diagram, we saw a width of x plus 2 and a length of x plus 3, and we learned about how that can be used to create a quadratic equation. That can be either the product of those two, or it can be x squared plus 5x plus 6. But what about the implications for quadratic functions, particularly those that we would see on a quadratic graph? We're going to take a look into Desmos for a moment to see what happens when we graph these not as the combined x squared plus 5x plus 6, but as the product of those two factors. So I'm going to open up a tab for Desmos. In this Desmos exploration, you can see that we have a parabola and we also have two parallel lines. They don't have to be parallel, but the key here is that we have these two lines and that the quadratic function is actually the product of these two linear factors. I'm turning on projector mode just to make things a little bit easier for participants to see. If we go over here, we can see a couple of things that are very important. What I've done is I've set up the equations in a particular way. Our parabola is y equals a times y1 times y2, the product of a scalar and two linear equations. y1 is x minus p, and y2 is x minus q. And then I have sliders set up for a, p, and q. You'll also see that in this particular Desmos activity, I've set up equations to display what the values of y1 and y2 are. Let's go ahead and do some playing around. I'm going to start changing p around and seeing what happens to our quadratic. As I start changing p around, not only is my equation changing, but I'm also seeing that my intercepts are getting closer together in value. However, what's more interesting is that the lines are moving with the quadratic function and continue to represent the x-intercepts. In fact, the x-intercepts of both lines happen to be the x-intercepts of the parabola. Let's keep exploring. This time let's change q. Again, No matter where I move p and no matter where I move q, the two linear functions have the same x-intercept as the quadratic function. This is particularly important as groundwork for why the zero product property works. When we think about the zero product property, we can see that when we break it up into the two linear factors, we can treat either one as 0 to determine the x-intercepts. Let's go ahead and play around with the scalar just to see what happens. No matter how I adjust my scale factor, or a, I still end up with those x-intercepts totally unchanged. In fact, the scalar has no impact on where those x-intercepts are located. I hope that this video helps teachers create classrooms where students explore math, observe patterns, and develop conceptual understanding. If you have questions, comments, or have a video idea, please email me at the address below.